Yeah. Okay, on this video we will be doing a tutorial for the microwave. This will be a full tutorial. I will be explaining um, not everything but almost everything on the microwave, so that it can assist whoever wants to repair microwaves. Okay, ngicela uze lana usondele. Okay, by the way, asiqale la. I-microwave yethu le, as you can see on the front, that's how you operate it. You set your time here according to your requirement, then you will start, then the microwave will work. But on this video, I'm not teaching you how to use a microwave. I'm teaching you how to repair a microwave. We know that we use our microwaves to warm food. So whenever the microwave is no longer warming food, then we have a problem. That's where appliance repair guys come from. This is a platinum microwave. You can come on this side. Microwaves have brands. So the brand for this one is platinum. And you will have a model number or a serial number. There is this will assist whenever something that cannot be repaired on this microwave must be bought. Then you will give them this number and the brand. So you call these guys. I've never tried to look for spares on microwaves for platinum. I think it will be hard to get spares on this one, but on this one, um, this one, this one is a Russell Hope. So we do get spares for Russell Hope. Samsung, LG, we do get space for the well-known brands. But the problem is with microwaves, as I repair appliances, when a microwave is like this one and this platinum one, they are using boards. Please come over here. They have these control boards for the operation in microwave. Whenever there is a component that cannot be uh, bought, or you try, let's say maybe this relay. I think this is a relay. Whenever this blows and you are trying to get the replacement for it and you don't get it, then you start looking for a board. Then when you get a board, in most cases the board is expensive. It will be 60% price of a new microwave, or even 70% price of a new microwave. Then that's where clients fail to pay for their appliances. So we end up keeping them, or they sell them to us for space. So that's the hardest thing on microwaves, when you have to replace the pots. They are expensive, but that is very rare, though it happens. Yes, boards do get blown and be beyond repairs, so you need a replacement, but it's not common. The common thing on microwaves is that it will not warm food. When it's not warming food, I assure you, you can fix it. But when the microwave is giving a problem, when a client is trying to program it or to set it, it's not starting, then on such cases, it's always the board. So that's where it's gonna be hard to fix. Let's say you have to replace the board, then it's gonna be hard to fix. But when it's transistors and resistors and capacitors, that thing, I assure you, it can be fixed. So let's come on this microwave. I want to explain why a microwave will not warm food. Like this one when you start it, it works, but the problem with it, it was not warming food. So this is the main guy that warms food, a magnetron. But a magnetron will not warm food when this fuse is blown. It will also not warm food when the capacitor is not working. Here we've got a high voltage diode that is connected here and to the frame of the microwave. When this is blown, the microwave will not warm food. Again, the microwave will not warm food when inside here, let's come here. This was for testing. There is what we call a waveguard there. When that waveguard is having holes or it's also blown, the microwave will not warm food again. So how many things you check for when the microwave is not warming food? You first open, check the waveguard. If the waveguard has holes on it or it's bent, the microwave will not warm food. Should the waveguard be okay, you need to open the microwave. On that case, the microwave must be starting and working normally, but not warming food. Okay, I've got this little example here of a waveguard that had a problem. This is the waveguard, right? You see, this waveguard had a hole here. So that is why the microwave was not working. And if you continue to use a microwave that has a damaged waveguard, you're going to damage the magnetron. So on the case of this microwave, this was the waveguard that I removed on it, and by that time the magnetron also was damaged. So let's say you've replaced the waveguard and tested the microwave is still not working. I'll be honest with you, I've heard that there are some guys that claim that they can test this thing and see when this thing is not working. On my experience as a person who repairs these things, you cannot test this thing. I don't even waste my time testing this thing because I'll show you. I've got one magnetron that is not working. Just wait for me there. Um, um, this is the magnetron that I removed on this microwave. So they say you put it on resistance, then you measure the resistance here. Some say that when you measure the resistance on this microwave, it measures right, and it measures the same resistance with this one. So according to their technique of testing it, it's not working for me. So what I do, as I've said, I test this capacitor and I test the high voltage diode, this guy, and I test this one. In most cases, this fuse, when it's blown, the magnetron will not work. As I've said, when this is blown, the magnetron will not work, even if these two are working. When this is blown, even if these two are working, the microwave will not work. When this is blown, even if these two are working, the microwave will not work. So when my waveguard is right, this is the first suspect. I come and open here to check if the fuse is right. If the fuse is right, I check the capacitor and I check this. When these three are okay, it's very rare for a microwave to damage the transformer, which will also affect the microwave on warming side. So I do check the transformer. I check the continuity of the windings to see if the transformer is right. When the transformer is right, I know that it's the magnetron. I just replace the magnetron, and in most cases, the microwaves will work just fine. Just for experience, this one, when I replaced the magnetron, it it made this damage. So I'll just have to make sure that I get the other lug cover for this one, then I test this one. So how do you see when your fuse is not working? You can also do a visual inspection on a fuse. You just take the fuse out, you open it. So you see this one, you must open here and open here, open, then we'll see there is a fuse here. So this fuse is working 100%. You can see that the wires inside are still connected. So the fuse is working. If you want to, you take your meter, some put it on big scale. I just put it on resistance. Mine measures resistance there. So when it's on resistance, I can measure the continuity of anything without using the beep scale. We first check the leads. The meter is reading. Well, I must admit that my meter is having a little problem. So when we put it here, the meter is reading. So the fuse is working. Now let's come to the capacitor. You just put your meter on capacitance. Then you measure the capacity. Multimeters work different according to scale selection. So yours might not be like mine. But you need a multimeter to check these things. Now we can put the meter on capacitance, then check if this capacitor is working. On this case, for me to get the correct reading, to make sure that I'm getting the correct reading, I'll just remove that lug. By doing that, I am isolating one connection so that I can get the correct reading. I don't like testing things while connected in a circuit. So if I remove one, I know that I can trust my readings. The capacity is written what capacitance you should get when you measure it. You see, it's 1.0 microfarads. So I should get something that ranges there. By the way, this is a non-polarized capacitor. That means there is no negative and positive on it. So let's measure. So you see we are getting 0.998 microfarads on the meter. So that 0.9988, it's fine. It's the capacitance that we are supposed to get according to what they have written here. So this is the big guy. You cannot put this meter on diode and measure this diode like that. This is a high voltage diode that cannot be measured like that. You can put this meter on diode to measure these diodes, small diodes for boards, but not this one. So I had to come with a way of measuring this diode. So I will share it with you. Let's come to this microwave. Okay. I do welding and appliance repairs. So I removed this on my cordless drill. It's a lithium battery for my cordless drill. It's ranging between 10.8 volts DC. So I use it to measure this or to check this high voltage diode. So according to my meter, what am I getting here? Okay, this lead is not touching. Let me make sure that this lead is touching here. Yeah, I'm sure it's touching now. Let's put this wire at the back. So this battery has 11.9 volts DC. So when you want to check these diodes, these high voltage diodes, I'll have them. I don't have a diode that is not working. I was gonna measure it, and you are gonna see what you will get when this diode is not working. But on this case, I will just tell you. So this diode, you remember a diode, if you did the theory of diodes, you know that there is a time when a diode is a reverse bias, and there is a time when a diode is forward bias. What forward bias and reverse bias means is just that it just tells you that there will be time when the diode will allow electricity to pass, and there will be a time when a diode will not allow electricity to pass. So a diode is working when it's allowing electricity to pass, when you twist it around and allowing nothing to pass. So on this case, we've got 0 because there is no connection between the two. So we expect a diode on one direction to give us a 0. That means nothing is happening. But on the other direction, it should give us a reading. That means the diode is allowing electricity to pass. So like anything, the diode has its own resistance. So when we put it on a circuit in series, we expect it to drop the voltage. Just like any resistance that you will connect in series here, it will drop the resistance depending on it will drop the voltage depending on the resistance. So let's go. We've got this diode connected now in series with this battery, and this meter is in series to help us detect if this diode is working. So we're measuring now, we are in series, so we are getting 0.011. So that means nothing. On this direction, this diode, it's allowing nothing. Now we are changing the direction. Let's check if this diode, remember we said the diode on the other direction, it will allow nothing. On the other direction, it will allow electricity to pass. So let's check. So now we are getting 8.79. That means on this direction, the diode is allowing electricity to pass. But as I've said, it has its resistance. So it's dropping the 12 volts that we got when we measure direct to the battery. So on this case, the diode is working. So when you are sure that the diode itself is working, the high voltage fuse also is working, the capacitor is working, and the transformer is working, all you have to do is to replace the magnetron. You can search wherever you want, or on effective ways to test the magnetron. If you happen to get them, you will be happy, and I will be happy if you share that information with me also, because as I've said, I don't waste my time testing this. I just test this and check the waveguide, and then if they all working, I replace the magnetron. If there is something that is not working here, I will first replace it and test the microwave. Should the microwave work, then everything is done. So there are times when they will call and say the microwave, it's off, it's doing nothing. So on those cases, you come here. When the microwave is not switching on, you come and check this ceramic fuse. Just like we have tested this on resistance, This one you cannot see it visually. I've got a lot of these fuse that I keep, so I will just show you one. Oh, this is the high voltage fuse. Here are these ceramic fuses. So let me just remove it here. See, you cannot see the internal wire on this one. So you need to test it. When you test it, it should give you something. If it's giving you nothing, then you just replace it. If the fuse is right and you're still getting, the microwave is still off, this is the supply, right? This is the supply. It's just that we're doing this video while there is no electricity. Actually, I was just bored because of load shedding. Then I decided to make this video. I usually don't have time to make such videos, but I'll try to make time because it seems like some people do like them. So you will put this on your plug, and then you come and measure here according to our voltage range in South Africa. You're supposed to be getting plus minus 230 here. Should you get that one, remember this is a high pass, this is a filter. Yes, this is a filter. So what they do, they take in this electricity that comes from the plug on your wall, then they filter it before it goes to the main board. So you need to come and test here if you do have 230. If you do have 230, then you continue and test here. If you do get 230, that is going to the board. If you do get that 230, that means your fault finding continues. So this is what they have done in the microwaves. This will take time if I explain everything, but let's try. I'll just take my side cutter and cut this so that you don't cram. You understand what I will explain. So now we are saying they are taking electricity to the board, but before they do that, you see what they do with the wire. So they put this thermistor here, they connect it in series. What they are doing here, they want to make sure that if maybe you set this microwave to 6 hours and there is too much heat on it, even this metal is starting to get very hot, this thing acts as a fuse. So when there is too much heat on this metal, it will close. It will just, oh, it will, I mean, it will open. It will not close. It will open. It will make an open line here. Then it will cut the electricity. So you've got this electricity coming here, so there's too much heat, then it will cut the electricity. Like, well, what I mean by that, it's like it's disconnecting. It's like it's disconnecting. Like when I remove this, that's what it does. It's like it's disconnecting when there is too much heat, but closing, like it's connecting when the metal is on low temperature or on room temperature. So that's what it does. So before it goes to the board, it starts here. Then they take this one to the light. Okay, but you see what they do here. The light will not come on when this thing is not working, but should the light come on, that means this thing is working. But you can also put your meter on ohms and measure here. Should you get continuity, then this thing is working. This thing is not likely to give problems also on microwaves. So we are tracing this wire. They are doing this for safety, so don't breach this, always replace it. So again, for safety, they don't take this wire, this live wire, straight to the board. They take it to this and they come to the light and they bridge it. Then they take it to this switch. Why are they taking it to the switch? They are trying to make sure that a microwave will not work when it's open. So when you close here, that pin there presses the switch down. And when it presses the switch down, it's creating continuity. When you open, it's cutting, it's opening. So you need to also check that if the microwave is not working, it's not switching on, and you've checked the fuse and you've seen that there is electricity, and electricity is passing there, and it's passing here and it goes there. You need to check if does it come out when you close here. Should it not, then you need to replace this switch. So now from this switch, we've got this wire. See this yellow wire. This yellow wire comes to the motor. That means whenever that switch is not working, your motor will be affected. And it also goes down that black. That black goes down to another switch here, which has 3 contacts. So again, when that switch is not working, because those 3 contacts are supplying, you've got one wire there, which is the blue wire, and the other blue wire, which is this one, this blue wire that comes here to the board, and that other one goes down to the motor here. We've got this tilt table motor, the motor that spins whatever you are putting on your microwave. So whenever that switch is not working, we know that that motor down there will be affected, and the blue wire that comes here will be affected, and this red wire also that comes to the transformer will be affected. So we need to check that one if it's working or not. When you remove these switches, they've got a drawing that tells you how the contacts are working. So you just put the meter on pip, you read the drawing, then you put the meter on pip scale or on ohms to test if the switch is doing what it's supposed to be doing. There is also this one, this switch. You can see that this switch is only connected to the board here. So you just need to remove that switch and test it and check if that switch is working. So all these switches, they have something to do with this board, and we've seen that one switch has had something to do with the motor, and the other switch has something to do with the tilt table motor. So when you've checked all of these and you've seen that they all working, then the problem will be to your board. Then you need to take out the board and check if you don't have any components that are damaged. Maybe it's the capacity or something. So when you have a problem here, that could be fixed, or you've got a component that can be replaced, you just replace that component and your microwave should be good to go. So I hope that this tutorial had given you enough information to be able to fix your microwave, but as you might have noticed, you would need to buy testers, screwdrivers to open these things. If you're willing to do that, you can do that. But sometimes a price for a tester, it's it's sometimes less than the price that you will pay the guy that will repair your microwave. So it's better if you just take your microwave to a reliable appliance repair guy to repair it for you. If that's not the case, then just use the information that I've given you to repair your microwave. It should work. Um, that was it. If you feel like we've got the content that add value to you, then you subscribe to the channel, like and share the video. Thanks.